Welcome back. We're going to do a quick review of Concept 2. Most of you should have this in your notes, but maybe if you've missed class, you just want an audio recap. So here we go. Concept 2, Reflection, Refraction, and Absorption. So on the left-hand side, we have different types of materials. So we have transparent materials, and those are objects that allow all the light rays through and do not create a shadow. So on the right-hand side, we have a boy. We can see his face through the glass. There is no shadow. That glass is transparent. The second type of material we have is translucent, and translucent objects only allow some of the light rays through, and they create a very light shadow. So if we look at the girl to the right, we can see her smile, but we do see a bit of a shadow. It's not completely clear. The final type of material is an opaque material. And opaque materials let no light rays through, and they create a full shadow. You notice from the hair, we have the same boy in the first picture, in the third picture, and we cannot make out his facial expressions. You can't see his face. Absorption, transmission, and the reflection of light. So there are three different types of interactions we can have with light. So light can be absorbed, and when light is absorbed, it means that the light rays strike a surface, and the light energy is transferred to the surface of the material. So this transfer of light energy is typically thermal energy. So if it were the summertime and we had the sun's rays shining on us and you were wearing a black shirt, you would have, that light energy being transferred into thermal energy, and it would make you warmer because that black shirt is absorbing the light energy. The second example we have is transmission, and that's very similar to transparent materials. And that's when the light rays are able to pass through the material and it goes right through, so no issues. Reflection. So this is when light rays bounce off a surface, and this is usually when the material is shiny, smooth, or lightly colored. So it could be a shiny piece of metal, such as a plane mirror, or maybe you're wearing, could be like an aluminum foil, but essentially we're getting a nice reflection back from the initial ray and then that reflected ray. So let's go through an example of labeling a diagram that includes reflection. So the first thing that we have is our normal line. Our normal line is an imaginary line that is 90 degrees or perpendicular to our surface. So we're not sure what the surface is, but it's probably a reflective surface or a plane mirror. Okay, and this is usually marked with a dotted line. The next thing that we have is an incident ray. And the incident ray is the initial ray that strikes that surface. And you should include arrows. That way you know exactly what the initial direction is and where it's going to hit. So this is what I've done with the orange line here. Now the angle of incidence is the angle between the incident ray and the normal line. So it's referenced here with this eye. And now it's been placed with that red little marker. The blue line represents the reflected ray. And the reflected ray of light is the ray of light that is bouncing off that initial surface. And again, there are arrows here to show you the direction of the light. The angle of reflection is the angle between the reflected ray and the normal. So what was the takeaway of that? Well, the takeaway of that was that the law of reflection states that the angle of reflection is equal to the angle of incidence. So if there's anything that you took away from this, the angle of reflection is equal to the angle of incidence. There are two types of reflection. There's regular reflection, and that would be when our plane mirrors or any other surfaces produce a reflected image. So notice that our incident rays, they hit the surface and they bounce off uniformly or nicely, and they form these reflected rays. And they're all going in the same direction. Diffuse reflection is where we get a surface that is not uniform. It's not smooth. It's not nice. There are divots, maybe cracks. It's just causing the light rays to hit unevenly, and then the reflected rays scatter, and therefore we cannot get a reflected image. Types of mirrors. Most of you are familiar with plane mirrors, and those are the flat mirrors that we typically see in our bathrooms, in our homes, right? Concave mirrors are mirrors that are curved inward, so they make a cave. And two interesting facts about concave mirrors is that sometimes they cause images to look inverted or upside down. And concave mirrors are used for magnification, so you'll see them in microscopes, and you'll also see them in telescopes. Convex mirrors are a mirror that is curved outwards, right? So if we're looking, the initial ray comes here and they are diffused out. Convex mirrors are usually used in security systems, so convenience stores. If you're driving a vehicle, you'll see them used as side mirrors, and it will say object may appear, object may be bigger than it appears or closer than it appears. So the objects or the images tend to look smaller, but it gives you a wider field of view. Refraction. Light travels in a straight line through air, but when it goes from one medium to another, it moves at a slightly different speed, or it moves at slightly different speeds, sorry. When light enters a more dense medium, it moves slower, thus bending towards the normal line. When light enters a less dense medium or substance, it moves faster, bending away from the normal line. So the way that I remember this is that humans are typically on land, and humans typically look in air, and sometimes while they're looking through air, they might look through water. So if they were looking through air and then trying to see through water, that's normal. That's typically normal, right? Let's say you're fishing, you're trying to see the fish in the water, you're looking from air to water, the light rays are going to bend towards the normal. That's fishing. That's normal. When light enters a less dense medium and then moves to when light enters a less dense medium, it moves faster. So to get the opposite of that, if humans were in water, which is dense, and then trying to see in air, well then that would not be normal. So that would be bending away from the normal. So I'm not sure if that analogy helps you, but for me, I think of fishing, and when we're fishing, we're in air and we're trying to see. So that's how I remember. When light changes speed, it bends. This is refraction. So anytime light changes speed, we call it refracting. Let's go through our final example to wrap this up. So at the top we have our medium of air, and at the bottom we have our medium of glass. We're going to draw that normal line, which is that imaginary line that is at 90 degrees or perpendicular to our surface. Notice that it goes through both mediums, the air and the glass. We're now going to label and draw our incident ray, which is our starting ray, which is traveling towards the surface. It starts in the air and then travels through the glass. We have our angle of incidence, and that's the angle between our incident ray and our normal, that purple line. The ray that travels through the glass is our refracted ray, and this is the bent ray as a result of the change in medium. So we're going from air to glass. This is our refracted ray. We have our refracted angle, or angle of refraction, and the angle of refraction is the angle between the refracted ray and the normal line. I hope this quick review of Concept 2 helps. If you have any questions or concerns, feel free to comment below or send me an email. Cheers.